Hello everyone. I would like to continue with our lesson calculating the volume of a solid using Washer method and example number 3. Okay, so in example number 3, we also work with two parabolas, but in this case you see that we have a parabola opens down. So this one right here, parabolas opens down, and this parabola opens up. So 1 plus x squared. So we are going to see that this is the point of intersection, and we are going to shade in the area. Okay, so we shade in this area that we are working with so that we can recognize the upper function and the lower function. Alright, so if I draw my element, it will be the vertical element, and I show the arrow here to indicate to everyone that your upper function will be the parabola opens down. So y2 is equal to 9 minus x squared, and your y1 here is the parabola opens up. So y equal to 1 plus x squared. So I would like everyone to compare the difference between example 3 and example number 2. So let's go back to example number 2. Alright, so in example number 2, what we have here is you have a parabola opens down. So 8 minus x squared opens down, and the parabola opens up. The vertex is at 0 and 0. Okay, so this parabola opens up. The vertex is at 0 and 0. Okay, so for this example number 3, the vertex for this parabola is in fact 0 and 1. Okay, so this point here is not at 0, 0. So this will affect the shape of this solid. So let's indicate that is rotate about the x-axis. Before I continue calculating the volume, I would like to show everyone the 3D image of that one. Okay, so let's go to our 3D image. So this one is example number 2. Alright, you see right here this point is 0, 0. So I'm going to indicate to everyone here is 0, 0. Okay, so if I raise this parabolas up, okay, to have it 0 and 1, and what kind of shape that I'm going to have. Okay, so this one is our example number 2. Alright, so we are going to have a shape that look like this. So this is the cross section area, half of this solid, and this one is a full solid. So if I place them on top of each other, for you to see what they look like. Now, example number 3, okay, if I raise the this parabola, okay, above the x-axis and here 1 unit, then I will create a hole. Okay, so right here you don't have a hole in the middle of this one. Okay, so that's the shape that you have. Okay, you don't have a hole, but this one you will have a hole, which is the gap right here. Okay, so again, to tell everyone that this is just my ear pod beside this, so that this one can stay in this position for me to take an image. Now let me show you if I generated it into the full shape. I will have like a shape like a donut with a hole in the middle. Okay, and if I place them on top of each other, you see that you are having a hole here because you raise the parabolas up. Okay, so I'm going to draw the axis through this. So right here, it should be right in the middle. So I'm going to draw a line, x-axis straight to this, right? Okay, and here is my y-axis. Okay, so this is y, this is x. Rotate about the x-axis, and this one right here, so this one is y2 equal to 9 minus x squared, and this one is y1, which is equal to 1 plus x squared. And the vertex that I'm talking about here is 0 and 1. Okay, if you let x equal to 0, y is equal to 2, which is the vertex of the parabola. Okay, so shaded the area that we have to work with to realize the upper function minus the lower function. Alright, okay, so this is the 3D image of that, the cross-section area, and I cut it in half. This one is the to show you that this is a half, this is the full shape right here, and then I put them on top of each other. It looks like that. Okay, so let's get back to our example, and then we calculate the volume of this solid. Okay, so first of all, I would like to mention this one is the two values for the upper and the lower limit, the a and the b. And the formulas we have to work with is v equal to pi integral from a to b, y2 square subtract y1 square, integrate in terms of x. Okay, so let's find the point of intersection. Okay, so I'm going to let the two equations equal to each other, so I will let y2 equal to y1. So I will have 9 minus x squared equal to 1 plus x squared. Okay, so moving everything over to one side, okay, I will have 0, 1 plus x squared plus x squared subtract 9. So I have 0 equal to 2x squared subtract 8. So then 8 will be equal to 2x squared. So a divided by 2 is equal to x squared. Therefore, x squared is equal to 4. Okay, so I can do like this. Therefore, x squared is equal to 4. So x is equal to plus or minus 2. Okay, so everyone knows at this point that I should have x squared equal to plus or minus square root of 4. Therefore, x is equal to plus or minus 2. So I'm going to show everyone the 3D image below is like this, using Mastercam to sketch. So that's what I've got. Okay, so let me square the upper function and we square the lower function. So we prepare ourselves for the integration process. Okay, so y1, so let's do the y2 first, will be equal to 9 minus x squared, all of it squared. So 9 minus x squared times 9 minus x squared. Here I should have 81 subtract 9x squared subtract 9x squared plus x to the exponent 4. Therefore, I have 81 subtract 18x squared plus x to the exponent 4. Okay, the other one is y1 square. Let me take this bracket away. So y1 square equal to 1 plus x square, all of it square, so it will be 1 plus x square multiplied by itself twice. So then I should have 1 plus x square plus x to the exponent 4. So therefore I should have 1 plus 2x squared plus x to the exponent 4. Okay, so we remind ourselves of this two expression, and we are going to take one away from the other. Okay, so that's the 3D image. Try my best using Mastercam to sketch this for everyone here. Okay, yeah. All right. You guys are all in mechanical engineering, so you probably know this already. So I'm going to take the y2 square, subtract the y1 square. Okay, so volume equal to pi integral from -2 to 2 of 81 subtract 18 square plus x to the exponent 4. Okay, so let's fix this minus sign. Here it is. Okay, I'm going to go step by step. Subtract in the brackets, don't forget it's a bracket, 1 plus 2x squared plus x to the exponent 4, and all of this is in terms of x. Okay, so this is my y2 square, this is my y1 square. So I make sure I double check so I don't make any error. So now we are going to open up the bracket, expand the brackets, or distribute 1 minus 1 minus 2x squared subtract x to the exponent 4. So this is the 4 here. Okay, excuse me, sorry. Okay, so let's see what term that we can cancel. So this term cancel with that term. So I should have now 81 subtract 1. So I should have 80. Okay, and this 2 I should have minus 20x squared. Alright, so this is the x. Okay, so now I should have it as pi 80x subtract 20 over 3 x to the exponent 3 integral -2 to 2. Okay, and I should have this as pi multiplied by the f of 2 subtract the f of -2. Okay, so we want to remind ourselves of that. So volume will be equal to pi. So I should have it as F2 should be 80 times 2 subtract 20 over 3 times 2 to the exponent 3. Here is subtract this with 80 times -2 subtract 20 over 3 times -2 to the exponent 3. Close this. So I should have this one as 320 divided by 3 subtract 320 divided by 3. This is multiplied by pi. This is the indication of this is my f of 2, and this one should be a minus, and this one should be my f of -2. Then in the end I should have this as pi 320 over 3 plus 320 over 3. So in this case, the answer should be 640 over 3 pi unit cube. Alright, okay. So let's double check our work. Okay, so I think the integration should be simple because we have done this so many times already. Okay, we just want to make sure all the algebra is actually correct. Alright, okay. So in using the washer method, it's very simple. We just follow the formulas. Okay, follow the formulas that are given to us. How do we recognize the upper function and the lower function? Is to shade in the area and draw the vertical element to see the upper function is here and the lower function is there. Recognize the difference between how the shape supposed to be if we raise certain values for the vertex. So instead of having the 0, 0 here, I am pulled it up here. I have the values as 0 and 1 for the vertex. Okay, so let me put in here is this is 2 and negative 2. Okay, and this one here, the vertex is 0 and 1. When x equal to 0, y equal to 1. And the shape or the solid will have a hole. Okay, so we'll have the hole in the middle. Okay, so let's go back and see the shape again. Okay, so this is the shape that we supposed to generate, and as according to that area that we work with. Okay, again, here we are having the y-axis. Okay. Okay, I just want to draw a straight line through this, like our y-axis here. And this is the x-axis. Okay, and that's the half, and this is the full area for this. All right, everyone. I think if you have any questions for me, you can go ahead and send me an email. Okay. All right. Thank you.